So we can have this. All right. So if yours still says part 1, just cross that out and put part 2. So I forgot to put the corrected version up. All right. I threw all the key terms on here again because they'll probably show back up on the test for you guys. I wanted to just keep them fresh in your minds. So there's just a lot of picture slides in this PowerPoint. Through this leukopoiesis chart on there for you guys again, in case you really, really liked it and want to make a blow up poster. It's there for you. All right, so granulopoiesis, or depending on what book you're reading, it might be called granulocytopoiesis, but all that is the hematopoiesis of granulocytes. That's all it is. And it primarily occurs in your red bone marrow. Now, as far as all of these are concerned, I already tested you on that, so I'm not retesting you. I just wanted to put them there for you to remember. You had their stem cell, which went to a myeloblast and a promyelocyte, then a myelocyte, then a metamyelocyte. And if it's a neutrophil, then it goes to a stab cell. Otherwise, it just turns into one of the other ones. But this part is not going to be on your test again. We already did that.
Oh, I forgot. I wanted to tell you, so many of us kept having heart attacks this weekend because we kept getting alerts about the test, and we were like, "Oh my god!"
Oh, it sends alerts?
Yeah, it was sending us like emails and then Edmeto alerts, and we were all like, "Wait, what's due?" And then we're like, "Oh wait, we forgot she reopened
I'm so sorry. Most everybody took this stuff. I still have several people that haven't taken some of the tests. So for the final, that's going to happen again. I'm going to re-release all of them. So I apologize. I didn't know that it was going to do that. I'm sorry. I'm so sorry. But at least it reminded the people that needed it to like do it. Most of them anyways. So this is just another picture. I found this also on Pinterest. It was probably a project or something for school. And I just thought it was, I hope they got an A on it because it's really good. It goes from immature to mature, and they just kind of showed what it looks like. So slowly the cytoplasm is losing its basophilic color, and you're going to get more granules as it matures. So I just thought it was kind of a neat little picture that somebody did. I would have given him an A. It was pretty good. Good job. Here's some real pictures of what they would look like. We are not doing ID on this test. That's going to be just way too difficult in the virtual world. But I wanted to at least make you familiar with what they look like. And then we get our EOs. So all of the eosinophils and the basophils that you see in the book are very obvious eosinophils. They are red eosinophils, but in real life, not so much. Now, I used to do individual ID on canine, feline, equine, bovine, but it looks different on my computer than it displays on the board at school. And I can't assume that everybody has the same screen resolution as me. Like I'm seeing orange, and some people are not seeing orange, they see purple. So what I'm going to do for testing you on each individual one of these is when we get to those slides, is I'm just going to use the words, and I will describe the eosinophil, and you have to tell me what species I'm talking about. But for the most part, most of them are going to stain kind of a red. So the cytoplasm, if it's mature, he's going to be nice and red. And depending on what species you're looking at, all the granules are going to be different. But just like a neutrophil, all of those adult cells are connected in lobes, and they're connected by chromatin. Excuse me. You can see they look pretty different between the species. The equine reminds me of one of those gumballs that you get that are like bumpy lumpy. I love those. They taste good for like 30 seconds and then that's it.
Do you know why the greyhound is different?
I do not.
Hmm.
Well, I mean, I know why it looks like that, but I don't know why it happens like that.
Right.
I tried to find out, and there's nothing that says what happens
Hmm.
to it. It just basically is like, well, because it is, and I saw. But it's not every single greyhound. It's super weird. Super weird. So this is more how I'm going to test you. So I'm going to say on the test, for example, this particular species, eosinophils, have round granules with a light blue cytoplasm. And you would have to pick from canine, feline, equine, bovine. But I wanted to give you an example of what they look like in real life, because sometimes I feel like it's good to look at the really red ones and good to test with the really red ones, but those have been stained for a very long time to get them to stain that way. So it's super easy for you to recognize. But when you get to clinic and you're looking at some of these, they're not always going to be so obvious. So I wanted to show you what they really look like if you just do a quick, 15-second dip. They're not going to stain that super brilliant, brilliant red. If it's a cat, their granules are actually rod shaped and they're more orange. So they're not a real circular type of thing. And he kind of looks more like glasses, like an alien to me. Jake is sleeping. We have bored him to sleep. He's like, ClinPath again. Okay. Then we have horses. Horses have very big globular orange granules. So on my screen, I can see the orange. I don't know if you can see it real well on yours, but when I tried to display it at school, whenever I did it, it was just pink. So just know the words. If you have a ruminant or a camelid, they look exactly the same. So they're very small, very round orange granules. It's kind of a fuzzy picture. That one actually really looks orange to me. I don't know if it looks orange on your side. Avery's like, nope,
It goes pink to
it's
me.
pink. Looks pink. I'm not going to show you these pictures for the test. It is just gonna be the words. So if you make flashcards, I mean, you could put the picture there, but I am only gonna do the words. And here is your greyhounds. So they kind of look vacuolated. Sometimes they can be confusing. They're going to try and trick you, and they're going to look like a monocyte. They might look like a toxic band neutrophil, but for some reason, these granules lack the myeloperoxidase, so they just kind of appear to be something else. They're really eosinophil, but you can see this same thing happen in any of the other hound groups or breeds, or you can also see this happen in, oddly enough, golden retrievers. Not all of them. Not every greyhound, not every golden, just every once in a while this may occur. So if you get a golden in that's got super, super itchy skin, and you run their blood work and you do a smear and you see a whole bunch of these, and you're like, oh, there's no eosinophils. They might be eosinophils. He just might lack the myeloperoxidase that's kind of making it appear to be something that it's not. So I'd probably run it through the IDEX machine, because these guys are going to try and trick you. Tricky.
Mr. Jones.
Yeah.
So we had to let our the dog we're fostering from school outside, and he's kind of crazy.
Uh-huh.
Did you go over the canine and feline eosinophil descriptions?
Yes. Do you want me to go back?
Yes, please. Sorry.
That's okay. Let me go back. There you go. So dogs are very round and light blue cytoplasm. And cats are small, rod-shaped orange granules.
Thank you.
You're welcome. Did you need the horses, ruminants, and camelids, or did you get those?
I got those ones.
Okay.
Thank you.
All right. So that website that I told you guys about had these really cute flashcards that I just wanted to put them on there because some people find them helpful. I just thought they were also really, really cute. Just has kind of the basic information on them. I'm gonna I have so much going on my screen that I'm trying to I can't see the bottom part. There we go. So their whole killing strategy is they go to the battlefield, which is called chemotaxis. Then they're going to recognize the targets. Then they phagocytize, and then they have a chemical attack, which is when they get very dramatic and they explode, and all of their granules are toxic to whatever the foreign invader is. They kind of look like they have a spectacle shaped. So they also have a life cycle. So they spend, oops, I need the text. They spend about 3 to 8 hours in your circulation before they actually move into your tissues. Some books have them at 1 to 6%. We typically say 1 to 3%. That part is not on there on the test, but know how long they spend in circulation. Then once they get into the tissue, they can never go back, just like a neutrophil. So they're going to live there and die there, or they're going to come into contact with something that destroys them. Once they do die, then just like the neutrophils, macrophages come in, phagocytize the dead. And if you have way too many of them in the peripheral blood, we call it eosinophilia. And if you don't have a whole lot of them, eosinopenia. Let's go to the next one. So they got 3 jobs in their lives that they are required to do. And they go ahead and they are part of the inflammatory process. So when you get irritated by pollen or whatever, these guys are coming to the party. They also play a part in the immunity process. And they also phagocytize. Phagocytosis. Not a whole lot of eating going on there, but they do a little bit. So these guys show up in areas that you're constantly exposed to things that are not good for you. So they could show up in your GI tract. So this would be, you'd have probably a lot of them, if you have any kind of parasites going on, you probably are breathing in things that's not always good for you, dust, pollen, all that stuff. So these eosinophils are there to kind of keep you safe. And you always see a huge amount on the skin. So if you do a skin scrape, catch a little blood on there, you'll probably see a bunch of eosinophils there because we touch all of the things. So we need to have some sort of protection.
So does this go like, besides cutting yourself, like a burn, a sunburn, or any kind of burns up there like that? Sunburn?
Yep. Mm-hmm. Mostly like a wound but yeah, it could be sunburn. If you have any kind of allergies too, like extreme allergies to stuff, like there's a lot of lotions that I can't even, it just, my skin says nope. Did I wake you up, Jake? I have to show you guys a picture later. I made him upset this weekend. Didn't I? Yes, I did. Okay. So here's part one, or job one. So this is, I don't know, we'll pretend it's a knee or something. The person fell down. So these little guys sense that and they get attracted to, and they're inhibiting all of these allergic reactions, anaphylactic reactions. And what they're doing once they get there is they realize that there's some sort of inflammation going on. So they need to release all of these antihistamines to kind of reduce some of that itching, swelling. I got bit by a spider this weekend. They sure didn't show up fast enough for me because, man, that itched and burned.
I cut my finger on the tape dispenser.
Oh no.
I don't know how, but it scraped.
Those little things are sharp too.
I was in a rush. I was trying to get the tape to
Mhm.
finish packing this package, so because I'm started to do the online orders at Target to help them out, and I just
Oh. So it was one of the big ones, not just like a little.
no, it was a little one,
Oh, was? Oh.
just to tape the bag closed so it could be put inside the box with the other items.
Oh,
Yeah,
okay.
no, it hurt.
Oh, I bet. So nothing to write here. This is just an example of the immunity process. So we're going to talk more about IgE more when we get to lymphocytes, but IgE shows up with this guy. So if he has to go ahead and kill some sort of parasite that you get infected with, what it's going to do is IgE attaches to it and it just makes it more noticeable. So like the video we watched of all of the things coming in to attack it and eat it, what it's doing is it's attaching, so it's kind of like a beacon for everything else. And then he also explodes at the same time, so some of his toxic granules can start to kill this parasite. So it's kind of dramatic. And here's phagocytosis. So they don't eat a whole lot, but they can eat a little bit. So they do have lysosomes in there, so if they do start eating anything, they have the little stomachs. But for the most part, their whole purpose is to degranulate and call everybody else. What causes a bruise? That's more like you would burst a blood vessel or capillaries. Could be capillaries under the skin.
So their main job is what again? What did you say?
Their main job is mostly this one, inflammatory response. But they do all three. They do all three. So I am going to do, I miss having the board because I used to like to leave this up on the board. So what I'm going to do is I'm going to rewrite this on the top. I'm going to put this up here. So these are typical causes of you having a lot of these eosinophils going on. And I love it that they put it with letters. A would be adrenal insufficiency. L, you may have an animal with a lymphoma or any other kinds of cancers. So basically cancers. The second L, I'm not even going to write on there. This is more of a human-based disease, so I'm not going to ask you about that one. E stands for eczema or any skin irritations. So you might see that with hot spots, for example. R, respiratory. G would be anything with a GI. So it could be enteritis. It could be parasites causing that enteritis. I, infections. So again, could be parasites or other. And then the last one, C, I am not going to put that on ours. This is mostly human. Like all of your collagen vascular diseases. Like I have SLE, systemic lupus erythematosus. So there are certain things that can cause me to become inflamed, and it just makes my eosinophils angry, and it just brings a whole bunch of them to the party. Yeah, I'm glad they figured it out, Avery.
No, I've had it my entire life, and it took 25 years for them to do a biopsy and finally figure it out.
Yeah. Some of the collagen diseases are difficult because you'll get the skin scrape, and then it's like it shows nothing, and then you come back, and then they're like, oh, well, this is what it is. But because you don't have that many of these eosinophils, sometimes it doesn't show up. Super crazy. So I'm going to leave that on the screen for all of them so you can, because
So
usually I'd have that on the board.
you said L and C are more human?
Yeah, so I'm not testing you on that information. Not at all. Then we can do basophils. So they're going to typically stain blue, also multilobular, least common. So because they are so uncommon, that makes it really hard to tell the difference between oh, I'm still writing in white. You can't see my white. Let me try it in red. Basophilia and basopenia. Because you have so few of these, you would have to like really be watching the animal consistently and taking blood smears every week so you could get a baseline. So let's say every single week, puppy A always has 2 basophils. So you always find 2 basophils when you do his blood count. Well, one day you do his blood counts and you find 4. Ordinarily, I wouldn't think 4 is, I wouldn't be too upset about it. But for this particular animal, because I know he's only ever had 2, now he's got basophilia. Or let's say one day he doesn't have any, but he always has 2. Now he's got basopenia. But because it's such a small amount, it's really hard to tell unless you're testing this animal every other day. You know exactly what they have. So trying to tell the difference between the two is is really difficult. So I wouldn't be too worried about that. Just know the terms. The
So it's
doctor's never going to be like, huh?
because there's a few of them.
Yeah, there's just so few of them that, you know, it could be the difference of one or two that is tipping the scale. Okay, let's see. So their whole jobs. Let's talk about their jobs just a little bit. So they release histamine, whoop, and also heparin. So these guys are kind of like hollering from the rooftops. So they're gonna go ahead and start. They're gonna recognize something. They're gonna release histamine, which starts that whole immune response and starts to get you inflamed. Like I got bit by a spider this weekend, so my basophils saw what was going on, and they're like, I need to let the rest of the body know that something bitter, and all of a sudden my leg swelled up. Like, so it releases histamine to call the basophils over, and then when basophils come over, I'm sorry, eosinophils come over, they're going to release antihistamines, which just kind of try and settle everything down. So it also releases that heparin. So it's going to increase your blood response. So now you have more being released into the system, so the body can go ahead and fix it. So this guy is kind of special too. He's got IgE inside of him, and that is immunoglobulin E. So when he sees something, he's also binding to it and triggering this release. The picture there is a super sciencey explanation. It's talking about the light chains and stuff, but little red area is actually where they're binding. So I'm not testing you on this picture. Just know that it has IgE in it. That is what's allowing it to bind. They're kind of cool little guys. They're few in numbers, but they're very cool. Should I leave that up there for a second? Are y'all good? Okay. And all right, so this is another one of those that can be really difficult to tell difference. In most of your books, it's going to show you this beautiful picture of a bright blue cell that you're like, oh, basophil. But in real life, canine basophils are really hard to tell the difference. So they look a little bit like a neutrophil. They will be a little more on the blue side, but it actually looks more like a ribbon that's kind of inside of the cytoplasm there. Sometimes you'll see some granules, but you shouldn't see a whole bunch of these. If it's a healthy dog, you're not going to see a bunch. I just wanted you to see that they actually look more like a ribbon, and you can kind of see some of the granules. I did zoom in really hard on that one, but it's really difficult to see the granules. Now, if I would have left this in the stain, or whoever did this would have left it in the stain, it probably would have picked up more of that blue. But in real life, if you don't stain it, stain it that much, it's going to look purple. Here's a feline one. So this one does stain a little bit more on the purple side, and you could see the granules here. I just wanted to show you that. And this is equine and bovine. Equines are very dramatic. They really pick up the stain very well. Bovine looks a little more on the pink side to me. And here's one of those flashcards. They kind of do the same thing. They're going to the battlefield, recognizing the targets, and binding it with that IgE, and then they explode. That's his whole MO. And then we got our monocytes. So he is the biggest of all of yours. And he is the only one that has a weird little, if you have an increase, we call him monocytosis if there's an increase. And if it's decrease, monocytopenia. And they will have vacuoles. They're really, really big. And they're really tricky sometimes. They try and look like everybody else. They're trying to they got to get their own identity. Let me show you this one. So there's a lot of words on this slide. Basically, what I just want you to know is he is really hard to identify sometimes. Sometimes he looks like a band cell. Sometimes he looks a little more on the pink side. Sometimes he looks lobulated, so he looks like a neutrophil. So just kind of look at the size. He's usually the biggest one, and there's no consistency. So everybody's going to look a little bit, every monocyte is going to look a little bit different than the other one. Sometimes the cytoplasm will have some vacuoles. If it's equine, they're going to look a little bit more like lymphocytes instead of neutrophils. So just look at the size. That's my biggest tip, I think. If it looks like you could fit like 3 red blood cells inside of it, it's probably a monocyte because he's just really big. Really, really big. Here's just some examples of how they can try and be little tricky tricksters. Like this canine one, if I was unaware and I didn't see any of the red blood cells next to it, I would go, oh, band cell. But then I look next door and I see that tiny little red blood cell, and it's obviously super huge. And you can see the size between all of the species. The feline one, actually, you can see the vacuoles in the stomachs, but the equine, actually, I would have assumed, if I hadn't seen the red blood cells, I would have assumed that was a lymphocyte. So they can constantly change. So their whole job is to go ahead and participate in the inflammatory response. They go and they clean up all the cellular debris and all the remains, which is basically, let me just put this up here, phagocytosis. And then these guys have a really cool job. So these guys have eaten everything up, and then they go searching for the lymphocytes, and they go, hey, look what I just got. And they kind of present it to them. They're like, I just ate this and I don't know what it is. Like kind of like a little kid. It reminds me, whenever I think of a monocyte presenting the antigens, I think of when my kids were little and they're like, I just licked this, what is it? And I would have to identify it. So that's the lymphocytes' job, is they would go ahead and figure it out and identify it. So they don't spend much time in the bone marrow or the circulation, so they just kind of go to the tissues. They can live there for like 100 days. And then what I do need you to know is this bottom part here. I'm going to put a line underneath it. The monocytes and the macrophages have a special term. They are called the mononuclear phagocytic system. So all that means is these guys are the ones that are super in charge. They do a lot of the phagocytic activity. So they're the ones getting in there and clearing out infections and clearing everything up and then presenting it to the lymphocytes. So they kind of have their own little group. So mononuclear phagocytic system, because they just have one nucleus And yes, they look like they're lobulated out, but it's not. It's just their shape. MPS.
You said that through phagocytosis, they then tell the lymphocytes what they ate. Like, hey, I ate this. What is
Yeah.
it?
So that's just the presenting of the antigens.
Oh.
So after they do phagocytosis, they go up to the lymphocytes and they show it to them, and then the lymphocytes continue on with the immunity process. So if you've already been exposed, let's say it's the flu, you've already been exposed to flu type A. He goes and he cleans that up and he presents it to the lymphocyte, and the lymphocyte is like, oh yeah, I know how to kill this, and he sends out the correct lymphocytes to kill it. Now, if it's something that this B lymphocyte has never seen before, he's going to send more neutrophils in because they're like, I don't know what it is. We're going to have to go back to the research department and check this out.
Mhm.
Let's just go and try and send a whole bunch of troops in and just kill it, see if we can kill it. So they're just super cool. I like to think of your body as like this whole little war going on, and they're just constantly working for you. It's so neat. Should I leave that up there for a moment? My dog is snoring right by my head.
Miss Regalia.
Yes.
So you said that the monocyte will present the antigens to lymphocytes. And what did you say the lymphocytes would do if they didn't recognize whatever it ate, basically?
So what they're going to do is they're probably going to send in a whole bunch more neutrophils. They're
Okay.
like, yeah, they're like, I don't know what this is yet, and they try and learn it. And in the meantime, they know the body needs still some help in trying to fight whatever this is. So it's going to just send out neutrophils to just try and eat it and clear it up.
Thank you.
You're welcome. Yes, so Miranda, I need to see that. Cells at Work. Everybody's been telling me about it, but I still have not seen it yet. I need to do that. All right, so here's one of those flashcards for you. So his killing strategy: go to the field, which is chemotaxis, eat, phagocytosis, and then he transforms. So he went from a monocyte and he transforms into a macrophage. Macrophage. So we get a couple other in the other category. So I wanted you to be familiar some terminology here that you might see in maybe your own animal's blood work. It might say histiocytosis is present in this particular animal. All this is an umbrella term. So histiocytes, umbrella term. Anything that is any kind of monocyte, it's derived macrophage. It could be a dendritic cell. They're not normally living in the blood, but they look like macrophages. So sometimes you can see it in reactive, sometimes you see it in neoplasia, some things like inflammation, IMHA, protozoa infections. One we already talked about, it was cytozoonosis. Let me put this in this. Cytozoonosis. So that can cause histiocytosis. Could be in lymphoma, could be in hemangiosarcomas. But if you're seeing a whole bunch of these, if they are looking really abnormal, then we would kind of start to worry about some sort of leukemia. Dendritic leukemia is a super rare form of leukemia. But these guys can also be an artifact of storage. So the monocytes got activated for some reason. This animal got seriously sick. All of a sudden, we have a whole bunch of macrophages. So these guys are just going to be there. They're just still present. So you did the blood smear and you're like, whoa, what is happening? So it's just because they're still in the blood. The body hasn't cleared them out. So this could be cancer or it could be nothing. So if you see histiocytosis present, it's basically because we can't really determine exactly what's quite going on. There's going to have to be further testing to determine exactly what's going on. Does that make sense? Okay. And I have a picture, and I'm going to flash between the two screens once I get to mast cells because they look real similar. So if I saw this one, I'm not really sure of this animal's condition. I would say histiocytosis is present. Let's say this animal came in and there's nothing major wrong. It doesn't have any symptoms. Everything seems good. He was sick like 2 weeks ago, but now he's doing better. And I ran his blood work and I'm like, boom, this is what I see. There's two of them on the bottom here that are like one on the top, one on the bottom that are obvious monocytes. But everything else, it just kind of looks like everything kind of collected in one area. So if I was the lab tech, I would probably say histiocytosis was present because I don't really know what's going on with this animal. So just generic umbrella term. Whereas your mast cells, so they look really, really similar to histiocytes, but you're not going to see them in an animal that doesn't have any disease. So they're going to have some sort of reactive inflammation, allergic reaction, could be cancer, mast cell tumors. So
is histocytosis basically like saying it's idiopathic, like they don't know?
not idiopathic, but more of like we need more testing to see what's happening.
All right.
Because obviously something happened to that animal to cause this to occur, but we can't really determine. But if the animal is not showing any symptoms, we're really going to have to dig a little deeper. But mast cells, on the other hand, the other thing with histiocytomas and histiocytes is they generally don't explode and degranulate, whereas mast cells, let me show you a picture. Where'd it go? Here's a mast cell tumor. So you can see how it degranulates. So this used to be that all those little bubbles on this side, let me circle it. All of these, that used to be a monocyte. But all of this is spilling out. And then these guys all came in to try and clean it up, which actually spreads the cancer. So this would be a mast cell tumor. This would be something that is cancerous. So they look really, really similar. Let me flash back to that other screen real quick. So mast cell, histiocytoma, or histiocytes. So everything is still pretty encapsulated here. Everybody's staying in their own little cell. But in a mast cell, things start to bleed out, they start to degranulate, and then other cells are coming in and they're trying to clean it up and spreading the cancer, and then they degranulate and it spreads and spreads. So I think the easiest way to tell the difference between the two is there degranulation going on? That's the best way. Here's just a picture. So this mast cell is going to mature in your tissue. His whole job is to recognize the targets, and then he also cross-links and binds, and then finally he explodes. He explodes. My cuckoo clock is distracting me. And that is it. That is the last slide I have for vous. Any questions on all that stuff? Do you want to move this so you could see that, or did everybody get the allergic notes?
I got it.
Okay. So I thought what we could do tomorrow is a big review. I have I think this one I have in the form of two, what do you call them? Jeopardies. So I have two Jeopardies. And then Wednesday test. And then Thursday, we're going to do the find something in your house and present it to us like it is a white blood cell and tell us the job of the white blood cell. I think that'll be fun. Something fun before Easter break. All right, guys.
I think the review will be good because there's just, I don't know. I just feel like there's a few things that get confusing on this.
On this particular slide,
Yeah.
do you want me to go back to one?
I don't know. I just have to kind of read through it and see what's, I don't know. Yeah. I don't know
Okay.
what questions I have yet.
All right. Well, we can go over it tomorrow for sure. For sure. This test isn't. I'm not gonna lie. It's not as bad as it would be in person because there would be more actual ID and stuff. This is going to be more. Let's talk about it and pick the correct choice type of a thing. But
Got it.
yeah, it'll be okay. You'll be fine. But yeah, come tomorrow with if you have any questions, let me know and I'll clear everything up before you take a test. Miranda's going to make some Cinnabons for us. I like cinnamon rolls. All right, guys. Well, I will see you tomorrow and we will do that review.
Have a good day.
Sound good?
Yep.
All right. I'll catch you later. And I will be posting, I still haven't posted last week's YouTubes. I will get those hopefully posted up there today. I've got 2 of my own tests to take this evening, so I'm gonna get those done. And while I'm taking my test, I'm gonna start uploading everything to YouTube. So,
Cool.
all right, you guys have a good day.
You too.
All right, see ya.
Bye.